Given the rational function f of x equals 2 divided by the quantity x plus 2, we want to determine the domain of the function, then complete the table of values and graph the function. The domain is a set of all possible inputs, or x values. To find the domain of a rational function, we want to focus on the values that x cannot be, and since division by 0 is undefined, we want to know when the denominator of x plus 2 is going to equal 0. Well, if x is negative 2, negative 2 plus 2 is equal to 0, and this would be undefined, which means our domain will be all real numbers, or all reals, except x equals negative 2. This also helps us in a couple other ways. Any 0 of the denominator that is not a 0 of the numerator will be a vertical asymptote, which means the graph of our function will have a vertical asymptote at x equals negative 2, which would be this vertical line here. This means the graph will approach this line, but not cross it. Also, when creating a table of values, we want to put x equals negative 2 right in the middle, as we see here. We know when x is negative 2, the function or y is undefined. So we want to select x values that are greater than negative 2 and less than negative 2. So it's usually a good idea to start with a value that's just a little bit larger than negative 2. For example, here we selected negative 1.75, and then select increasing values of x, and then select one value that's just a little bit less than negative 2, like negative 2.25, and then select decreasing values of x, as we see here. So now we'll perform substitution into the function to determine the corresponding y values and then plot the points. So we'll start with x equals 2. Notice if x is equal to 2 here, we would have 2 divided by 4, which is equal to 1/2. So here y is equal to 1/2. If x is equal to 0, notice how we would have just 2 divided by 2, which is equal to 1. If x is equal to negative 1, we would have 2 divided by positive 1, or just 2. When x is equal to negative 1.5, notice how the denominator would be 0.5. So we'd have y equals 2 divided by 0.5. Well, 0.5 is 1/2, and dividing by 1/2 is the same as multiplying by the reciprocal. So this would be 2 times 2, which would be equal to 4. When x is negative 1.75, the denominator would be positive 0.25. So we'd have y equals 2 divided by 0.25, which is equal to 1/4, and dividing by 1/4 is the same as multiplying by the reciprocal, which would be 4. So we have y equals 8. Of course, we could also do these on the calculator. When x is negative 2.25, notice the denominator here would be negative 0.25. So we'd have y equals 2 divided by negative 0.25, which is the same as negative 1/4. And dividing by negative 1/4 is the same as multiplying by the reciprocal, which would be negative 4 over 1, or just negative 4. So here we have negative 8. When x is equal to negative 2.5, notice the denominator would be negative 0.5. So we'd have y equals 2 divided by negative 0.5, which is equivalent to 2 times the reciprocal of negative 1/2 is negative 2. So we have negative 4. These last three will be a little bit easier. If x is equal to negative 3, notice the denominator would be negative 1. 2 divided by negative 1 is negative 2. If x is equal to negative 4, the denominator would be negative 2. 2 divided by negative 2 is negative 1. And then finally, when x is negative 6, the denominator would be negative 4. 2 divided by negative 4 would be negative 1/2. Again, if we need to, we can verify these calculations on the calculator. Okay, let's go ahead and plot these points. So we have 2 1/2 here, 0 1, negative 1 2, negative 1.54, So here up to 4. And negative 1.758 will be very close to our vertical asymptote, maybe somewhere in here, but not touching it. And then we have negative 2.25, negative 8. So just to the left of negative 2, we're down at negative 8. Negative 2.5, negative 4. Negative 3, negative 2. Negative 4, negative 1. And negative 6, negative 1/2. So you can see we have two pieces to our graph, and these pieces do approach the vertical asymptote, so they look something like this. And on the left, it would look something like this. So again, we had a vertical asymptote at x equals negative 2, but we also have a horizontal asymptote here along the x-axis, which would be y equals 0. Notice as x approaches positive infinity, this fraction here would approach 0, and if x approached negative infinity, this would also approach 0. This is the reason why we have this horizontal asymptote at y equals 0. Okay, I hope you found this helpful.